As you may recall from the other day, we had this. This was one of the review problems, and this was in from Chapter 8, and it's a hypothesis test for a mean against a standard. And in this situation, you have it's a ski wax and Bjork Larson. He's trying to decide whether to use a new, more expensive racing wax, and the new wax is supposed to decrease friction. And the reason he would want to do that, of course, is he wants to win more races. And if he wins more races, assuming he's a professional skier, he will make more money. Okay, so that's more or less the purpose of the research. Now I'm going to do the go to the checklist that we talked about the other day. And so you ask yourself, what would be an appropriate research question? Well, pretty straightforward. You just want to know, does the ski wax reduce course time? And what he's going to do here is he's basically to test this out. He's going to go down he's going to go. This is cross country, so he's going to go through the course 8 times and record his time and then average them out. Now, what is an appropriate null hypothesis? Keep in mind that the null hypothesis always includes equality. So you would say that the test mean time, the x bar, is going to be the same, okay, as the 55 seconds that he would normally take to get through the course. So there's no change. Okay, they're both the same, and that's the key phraseology associated with a null hypothesis. The alternate hypothesis is just the opposite. They are not the same. Not the same. And so whatever this sample mean is going to end up being you're going to say that they're not the same, and so you'd be inferring about the population mean for this ski wax situation, that they are not the same, at least for the alternate. Keep in mind the alternate never includes equality. You might say less than, greater than, those sorts of discussions, but there's never an equality. Okay, in this situation they're not the same, so you would say they're not equal. Which means testing would you use? At this point, you do not know the standard deviation of the population, so you're going to run a t-test. Right? And the other thing that's going on here is you're using an equality here, and as in the textbook, you're going to run a two-tail analysis. And the reason you knew that is because you got no sense of direction. Now, if this was less than or equal to or greater than or equal to something along those lines, then you'd be doing a one-tail. But as we've discussed, we're going to standardize on two-tail t-tests for the most part, because usually you don't know the standard deviation of the population, and your textbook makes a very good point. Essentially, it's a whole lot easier just to start out with the null that they're not equal and conduct a two-tail t. At what confidence level will you be conducting the testing? You're going to go at 95%. Another way to say that is p less than 0.05. Another way to say that is sig 0.05. It's usually written in script like that. Now, with that being said, you want to calculate the test statistic. Now, test statistic, there's a couple things you don't have. One is you'll probably be given these, and there are 8 races or 8 times that were recorded. So you'll either have to calculate those, or you'll be given what the x bar is for the 8 runs. You know that n is equal to 8. You'll also have to be given the standard deviation for the sample, which is 7.03. Okay, so you'll have to be given those. Now the other thing, as normal, that you will get as part of the exam is the equation x minus x bar minus mu over s over the square root of n. And at this point, you've got everything. You got x bar, which is 53.1. You've got mu, which you know is 55. That's the standard that's been set up. You've got standard deviation. You got the square root of n. You know what n is, of course. So you just calculate that out. And t is equal to 53.1 minus 55 divided by s, 7.03 divided by the square root of n. And if you ran that out, you would get a minus 0.77. A couple other pieces of information you're going to need here in order to kind of decide whether to accept or reject is to come up with your critical values. We know we're running this at a p.05 two-tail, and we know that our degrees of freedom is going to be 7 because the sample size was 8, so the degrees of freedom is 7, and the critical value is 2.365. Just going to move your finger across there. So it's going to be 2.365 on the negative tail and positive 2.365 on the upper tail. What is the p-value for the test statistic? Well, you won't have to do that exact. So, but what you've got now is you've got 0.77 or negative 0.77. So you know that your degrees of freedom was 7. So you run across, and you run out of chart well before you get to 0.77. The highest it goes is 1.45. So at that point, you know that your p-value is going to be greater than 0.2, and your standard is less than 0.05. So you can see where this is kind of heading, is that you're going to be accepting the null. Sketch the normal distribution with your rejection areas. Okay. Asymptotic. And this is 2.365, and this is minus 2.365. This is your do not reject. This is your reject zone. And you have another reject zone over here on the negative. So with everything set up, you've got your test statistic. You kind of know where this thing's going, and you run your test statistic minus 0.77. It lands here would be 0, and so it lands well within the do not reject. So do you reject or accept the null, or there's not sufficient evidence to reject the null, so you would accept the null. All right, the next thing you need to do is come back formally and reject the alternate. Mostly because you haven't gotten there. But if you had, in this case, if you had rejected the null, then you'd have to come back in and formally reject or accept the alternate based upon the evidence. What is the answer to your research question? Well, if you recall, the original research question was, will the new mean of race times be greater than or less than the target mean? So basically we're asking, are they going to be equal? And you know that they're the same. And so if this new ski wax, which is 2 times the cost of the existing ski wax, and it gives you no performance increase, or it doesn't decrease your race time, then your recommendation would be to forego buying or purchasing the new ski wax at a 95% confidence level. And you would say your p-value is well in excess of the standard of p.05. Your critical value is 2.365 at that 95% confidence level, your test statistic, and you use all this information to support your assertion or whatever your conclusion or recommendation is. And be sure to use specific values.